So now, some examples of finding the inverse of a one-to-one function. The instruction is this: find the inverse of the following functions if possible. So let's start. Number one, f of x. I'm going to call all these functions f of x, okay, for simplicity. So number one, f of x equals 2x minus 1. So if I want to find the inverse of this function, the first thing I gotta make sure of is that this function is one-to-one. How do we do that? We graph the function, which we already have done, because that's one of the functions that was over here. It's this function, can you see? And we graph it, okay, done, and then we run the test for one-to-one functions, which is that every horizontal line that you can draw at most cuts the function or the graph of the function at one point. If that happens, then this function is one-to-one. So in this case, it's one-to-one, and we can find its inverse. So let's do it. Let's go forwards again. Okay, so let's do it. How do we do that? How do we find the inverse function of this function? It's very simple. I mean, for simple cases, it's simple, right? For complicated cases, it's complicated. Okay, so in this case, it's going to be very simple. The general concept or the general method is this. You're going to write the function. Okay, then we're going to do a relabeling. I'm going to label again f of x as y. And I already told you why. Okay, next, all we need to do is isolate the x from this equation. We always have to isolate the argument. Okay, remember that the argument or the input or the independent variable is the x. And I need to isolate the x. So let's do it. We are done. X is equal to y plus 1 over 2. Okay, so now to finish, what you have to do is this. You have to write the inverse function in this way. You look at this, and then you're gonna convert, and this goes without explanation. Okay, if any one of you is interested in this, ask me in the chat. Okay, you're gonna convert the x to this symbol, f inverse of x. Just do it. Okay, and you're gonna convert the y to x. Okay, like so. X goes to f inverse of x, and y goes to x, and we are done. This is the inverse function of this function f of x. Okay, now let's confirm that. Let's confirm that this is actually the inverse function of this function. Let's confirm that this function undoes what this function does. I'm gonna do it in blue. Okay, so how can we confirm that? We can confirm that in the following way. Let's evaluate this function in some simple number. Let's evaluate f in 2. Okay, so f of 2 is gonna be equal to 2 times 2 minus 1, and so we have that f of 2 is equal to 3. Is that okay? So f of 2 is 3. F in the input of 2 gives me 3 as output. Okay, so if this is the inverse of this function, then when I give this output to this function, when I evaluate this inverse function in this output, I should get this as a result. Okay, if I give this as an input to this function, I gotta get this as an output. Okay, this function has to reverse what the function f has done. So let's check. Let's evaluate this inverse function in 3 and see what happens. I'm gonna do it over here. F inverse of 3 is equal to, according to this, 3 plus 1 over 2. Now let's run this calculation. This is 4 over 2, which is 2. So as you can see, in fact, when I evaluated f inverse in 3, I got 2. So f, again, one more time, f, when you give it 2, it gives you 3 as an output. And f inverse, when you give it 3 as input, it gives you 2 as output. So it's reversing, it's getting back to the original number that you started with. Okay, so in fact, this is a confirmation, and you can do that. You can do the same for every number, and it's gonna work out. This is a confirmation that this function is in fact the inverse function for this particular function. Okay, so that is the whole method. I'm gonna do it one more time for you. Okay, this function f of x equals x squared. Can we find the inverse of this function? Okay, again, first we gotta make sure that it's a one-to-one function. Okay, so we already graphed that function, as you may remember. It's this one, okay, and this one doesn't pass the test because any horizontal line is gonna cross the graph at 2 points, and therefore this is not a one-to-one function, and therefore we cannot find the inverse. This function doesn't have an inverse function, so we don't have to do anything in this particular exercise. Okay, number 3, the same is going to happen here. When we draw this function, we're going to see that the test for horizontal lines, the horizontal line will cut this graph of this function in more than 2 points, in more than 1 point, sorry, and so this is not one-to-one, and we cannot find the inverse. Okay, number 4, f of x equals 2 to the x. We have already graphed this function again. We have already graphed it. So it's over here. You can see this is the graph of the function, and again, any horizontal line cuts the graph at most at 1 point. Can you see? So this function is reversible. We can actually find the inverse of this function. So let's do it. Let's find the inverse of this function. I'm gonna write it down. I'm gonna relabel this number f of x as y. Nothing weird about that. And then what I want to do is isolate the argument of this equation, or this of this function. Okay, let's isolate the x. How do we do that? I ask you. How do I isolate a variable which stands as an exponent? With logarithms, right? I'm going to apply the logarithm base 2 in both sides. Logarithm base 2 of y equals logarithm base 2 of 2 to the x. I'm going to flip the sides now it's for convenience. Okay, and then I have log base 2 of 2 to the x. And one of the properties that we wrote some time ago says that log base a of a to the x is equal to properties of logarithms. Now I wrote 8. I wrote a new one, so it's 8 properties. So this is going to be equal simply to x, and that's it. We're done. We have isolated the x, okay, the argument of the function. And again, next what you do is this: you change the x for f inverse of x equals log base 2, and you change the y for x. I'm not explaining why this is happening, okay? I don't have much time, but if you are curious about that, either look it up or ask me. I will answer, okay? Okay, so this is the inverse function for this particular function. Okay, and you can make some tests in order to confirm that this is in fact the inverse function of this one. Okay. All right. Now, one last one. Okay, I only have time for this. F of x equals x to the cube. We haven't graphed this function, so what I'm gonna tell you now is a good application, a web application that it's free and that can help you graph functions. Because remember, we first need to graph this and see whether it's one to one. So let's do that. I'm gonna go out of the presentation for a moment. Remember the function f of x equals x to the cube. Okay, it's this application. Okay, it's called Desmos.com calculator. Desmos or Desmos graphing calculator. It's very cool. This application. It works very well. So what do? We want to graph that function. Okay, and you can either type f of x equals x to the cube. Okay, and as you can see, this is the graph of the function. Okay, or you can remember, since we are relabeling f of x as y, you can also do this. Okay, and we get the same. So whichever way you want to do it, that's perfect. I'm gonna keep this one. Okay, so the function x to the cube has this graph. Look at it. Okay, and try to imagine horizontal lines crossing at any point you want. Okay, horizontal lines. As you can see, it's only crossing the graph of the function at most at one point. Now you may think that in here it's hard to tell, but you can zoom over this section, okay, and you can realize that any horizontal line only crosses this graph of the function at most one. I'm gonna zoom in even more. Look, getting, can you see? More and more. Oops, it stops. At some point it's no longer very clear. Okay, but this function actually is one-to-one. Okay, because the test checks. So once that we are convinced that this function is one-to-one, we can go back here and try to find the inverse. Okay, so again, I write the function f of x equals x to the cube. I change f of x for y, and then I isolate dx. It's very simple. In this case, we take the cubic root in both sides. And if I take the cubic root on this side, what I get is x. Then I change the places like so. And then like I told you, we change x for f inverse of x, and we change the y for x. And this is, guys, this is the inverse function for x to the cube, which makes sense, right? It only makes sense. What is the inverse function of raising something to the cube? It's taking the cubic root of that, okay, of that number. That is the inverse process to raising something to the cube. Just like, for example, when you have a square, when you square something, what is the reverse process? Taking the square root, right? So it works in the same way. Okay, I think that's enough, guys. Try to do this one on your own. Okay, this is also reversible. You can find the inverse of this function and tell me what you got. So that's it. That's how we conclude the topic of introduction to functions. As you could see, it was very long. We saw many topics. We saw what a function was, what the domain and range were, how to evaluate functions, a one-to-one function, the inverse of a function, and all of these concepts took us a lot of time because you need to understand the concepts. The basic concepts have to be understood very, very, very clearly. Okay, that's the foundations of your knowledge. If that foundation is not solid, if it's not strong, whatever you put on top of that foundation is gonna fall down. Okay, so make sure to understand the basics, the real concepts clearly, and once you do that, the rest is it's a free ride. It's an easy ride. Okay, so that's it, guys, and see you later. Thank you.